Hello and welcome to my videos. My name is Ashish. And in today's video, we are going to see another method that is for sharing the data across the multiple threads, that is shared state concurrency. Message passing is a fine way of handling concurrency, but it is not the only one. Let's look at how communicating by sharing memory look like. And in addition, why would message passing enthusiasts caution not to use memory sharing? In a way, channels in any programming language. We have seen channels in our last video. Please go if you want to learn about uh, message passing to transfer data between the multiple between threads. You can check our last video. So channel in any programming language are similar to single ownership because once you transfer a value down a channel, you should no longer use that value. We have seen how compile time error is thrown by the compiler if you try to use that value. Shared memory concurrency is like multiple ownership. So multiple threads can access the same memory location at the same time. And we can use smart pointers. Basically, smart pointers made multiple ownership possible. Multiple ownership can add complexity because these different owners different owners needs managing. So Rust type system and ownership rules greatly assist in getting these management correct. So if you know about Mutex, if you have used Mutex in any other programming language, then Mutex is an abbreviation for mutual exclusion. Mutex allows only one thread to access some data at any given time. So to access data in Mutex, a thread must signal that it wants to access by asking to acquire the Mutex lock. The lock is a data structure that is a part of Mutex that keeps track of who currently has exclusive access to the data. Therefore, the Mutex is described as guarding the data it holds via the locking system. So Mutex have reputation for being difficult to use because you have to remember two rules. First is you must attempt to acquire lock before using the data. And second, when you are done with the data, the Mutex guards, you must unlock the data so other threads can acquire them. So for real world metaphor for Mutex, imagine a panel discussion at a conference with only one microphone. So before a panelist can speak, they have to ask or signal that they want to use the microphone. When they get the microphone, they can talk for as long as they want to and then hand the microphone to the next panelist who requests to speak. If panelist forgets to hand the microphone off, then they are finished with it. No one else is able to speak. If management of shared microphone goes wrong, the panel won't work as planned. So this was about the real world example. Let's look at API of Mutex. So for that, you need to import again standard library uh, that is from sync. You will see Mutex. And how to use API? Let's create variable m, and from Mutex we create new. So suppose I have integer. I want to share Mutex for integer, and it will be like this. So before we go with the thread, we can elaborate with inner block. So I will create another inside inner block. I will create another variable, another number from Mutex. We are acquiring the lock, and I can even modify the value. And last, I will print this value, and let's see if I have modified this value. Let's run this. Yeah. So you can see data 6, and it is saying, so this will, we don't have to worry about this poison. Okay, so this is how Mutex API works. Now let's look at how to create multiple ownership among multiple threads. So for that, there is one package called RC or ARC, Atomic Reference Counting, ARC, that we are going to need. So from this, we are going to need ARC and Mutex, and we are going to create thread. So we will be needing thread.spawn thread. All right. So now what we are going to do is we are going to create one variable counter. And so Mutex is already there. We are going to create ARC. So ARC is going to help you to create multiple ownership like this. So this variable we are not going to use. So we are not using any name to it. Let counter. So here we are creating clone And now what we are going to do is, next line, we are going to create creating handle for the for yeah we are now we are using move. Okay, and inside this, now let's create mutable variable from this counter. Now I can take a variable. Yeah. So here, so let's create, although it is not required, but we are creating handles, and this whatever handle variable we are creating, all right, and outside this for loop, we are going to iterate. We are going to call join method so that our main thread, so every thread will finish its execution, and then last statement will be main will get executed, main thread will get executed. All right, let's run this. Let's see if we are getting any. Yeah, so result is 15. We started with 5. There are 10 threads which are handling this. If you are coming from any other another language, so in terms, if you are coming from Java, then you must have came across synchronized keyword, something similar, or even mutex is there in Java. So this is how we can share data across multiple threads with multiple ownership and provide synchronized access. So this is how we create. So here we are creating multiple ownership. Without this statement, we are going to get error. We cannot use this counter directly, this outside counter, because we have not created ownership. So if I so here you can see borrow of move. So you need to derefer this. So this is how sharing of data happens using automatic reference count. I cannot use here RC, that is normal RC reference count. It actually has the same APIs. So instead of if I use standard RC, so it is not meant for. Let's use. I will show you. I will demonstrate you. If I use standard RC, not pointer. Yeah. So you can see cannot be sent between threads safely. That's the reason you have to use ARC here. So it is not thread safe, this RC. So this is create smart pointer, but it's not safe to share across the thread. That's why you have to use ARC, that is automatic reference counting. So that's it from this video. Please like, share, subscribe if you are liking the content. Thank you. Thanks for watching.